Page 3 of binomials addendum. We're going to talk about permutations here. Permutations is an arrangement of different symbols where the order matters. I think it's easier to understand if you take a specific example. So let's say you have the three letters A, B, and C. If you take each of these letters and you try to arrange them in different orders, there's different ways of arranging them. For example, there's BAC and there's CAB. Those are two ways to arrange ABC. And how many total ways are there of arranging the letters A, B, and C? There's actually 6 ways of doing that. And the way you could find that is you have 3 separate positions that you want to arrange the letters in. And in the first position, you have 3 choices. You could choose A, B, or C. Once you've chosen A, B, or C for the first position, for the second position, basically there's 2 letters left, and you could choose one of the 2 remaining letters. And then for the last position, there's only 1 possible letter you could fill in there. So basically, you have 3 letters possible for the first position, 2 letters possible for the second position, and 1 letter possible for the third position. You multiply those 3 together, and you get 6. And a permutation of a group of symbols is any arrangement of those symbols in an order. Okay. In example 9, there are 4 symbols. When taking 4 at a time, it is a big job to list each of the permutations. However, we can calculate the number of permutations without listing them by using a diagram. Okay, so just like we did up here, if you have 4 symbols to choose from, like A, B, C, D, then in the first position, you could put any one of the 4 symbols. In the second position, you've already used one of the symbols, so you can have a possible 3 positions you could put in that one. And then in the third box, you could put any one of the 2 that are remaining. And in the fourth box, there's basically one remaining only. And then to find the total number of permutations possible, you just multiply 4 times 3 times 2 times 1. So that would give you 24. Okay? It's just the product principle like we were using in the previous pages. I realize this might be a little bit tedious, but usually they only ask you to do this at the very beginning of, permutations unit. So what they're asking for here is that you have the symbols W, X, Y, and Z, and they're asking you, what are all the different ways you could order one symbol taken from this pool of 4 symbols? So basically, there's the possibility W by itself, there's the possibility X by itself, Y by itself, and Z by itself. So basically, there's 4 possibilities, and they look like this. Okay. What if you take 2 at a time? What are the possibilities then? So make sure you do this in an organized way. So basically, I have the WX possibility, the WY possibility, and the WZ possibility. So there's 3 starting with W. If I start with X, I would have the XW possibility, the XY possibility, and the XZ possibility. So there's 3 of those. And there's the YW possibility, the YX possibility, and the YZ possibility. And then finally, there is the ZW possibility, the ZX possibility, and the ZY possibility. So you can see there is actually 12 possibilities for that. And what if I take 3 at a time? What would that look like? Okay, so I could have WXY. I could have WXZ. I could have WYX. I could have WYZ. I could have XWY. I could have XWZ. I could have XYW. I could have XYZ. I could have WZX and WZY. I could have X, Z, W, or X, Z, Y. Whew, getting tedious. I could have Y, W, X, or I could have Y, W, Z, or I could have Y, Z, or Y, X, W, or I could have Y, X, Z, or I could have Y, Z, W, or I could have Y, Z, X. Or I could have Z, W, X, Z, W, Y. Or I could have Z, X, W, Z, X, Y. Or I could have Z, Y, W, Z, Y, X. So, how many of those are there? There are 6 times 4, there's 24. Okay? But there's also an easier way to calculate the number. You don't have to like list them all out. You could use factorials. Okay? Now in this next part, we have the symbols W, X, Y, Z, 4 different symbols. And we're going to figure out the number of permutations possible, and we're not going to use all the symbols like we have up until now. We're going to just use some of the symbols. So for example, let's say that you have one box to fill in only. How many different ways are there to fill in this one box with the 4 symbols W, X, Y, Z? There's basically 4 different ways, right? You could fill it with a W, you could fill it with an X, a Y, or a Z, and then you'd be done. So there's only 4 different ways, right? What about if you were going to take 2 symbols each time, and you were going to fill these 2 boxes with symbols? So in the first box, you could put 4 different symbols, any of the 4 symbols. In the second box, you've already used one of the symbols, so you could put any one of 3 symbols, right? So the number of possibilities here would be 3 times 4, which is 12. Finally, if you have 3 positions to fill, in the first box, you could fill it with 4 different symbols. In the second box, you could use 3 different symbols. And the third box, you could use 2 different symbols. So this would be 24. Number 3, in how many ways can 5 different books be arranged on a shelf? Okay, this is pretty similar, right? So you basically have 5 different books, A, B, C, D, and E. And then you say, okay, I have 5 positions on the shelf. How many different books can be put in the first position? 5. After you fill in the first position, then you're going to fill in the second position with one of the remaining 4, and 3, and 2, and 1, and so on, right? And if you wanted to calculate the number of different ways you could arrange the 5 books, then you would basically multiply all these numbers together. If you remember, the 5, 4, 3, 2, 1 multiplied together is actually 5 factorial. So if we wanted to figure out what 5 factorial is, the calculator actually has a function that does that. You could go to the math button, then probability, and then go down to factorial, and that'll figure it out. So we could put 5 factorial, and that would give us 120. Okay, that's basically 5 times 4 times 3 times 2 times 1. You could probably do that without the calculator. 3C. A signal consisting of 4 colored flags in a row be made if there are 10 different flags to choose from. Okay, so basically you've got 10 flags. So we have the E, F, G, H, I, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 different flags, and you're going to put them in 4 different positions. Okay, and like for example, one of the possibilities could be A, B, C, D. Another possibility could be B, C, D, E, etc., right? So how would you calculate the number of ways you could do that? You would say, okay, in the first position, you could put one of 10 flags. In the second position, there would be remaining 9 flags you could use, and then so on, 8 times 7, okay? So for this one, we're going to have basically 10 times 9 times 8 times 7. Is there an easy way to do that on the calculator? Yes, there is. Go to math, probability, and then you could use n permutations r. So basically what that means is you could do, you could do 10 flags, and then you put P for permutations, and then you choose 4 for how many you chose. So it would be 10, and then we'll go grab the permutations function. Permutation. And then we put R, which is 4. So it's 5,040. And the way you would find that is you could do 10 times 9 times 8 times 7, which would basically be 90 times 56, right? What do you know? 5,040. Another way you could do it is you could do 10 factorial divided by 6 factorial, right? So you could do 10 factorial, which you could find by doing math, probability, factorial, divided by 6 factorial. Math, probability, factorial. Do you see that? So a couple different ways of doing it. Number 5, how many different permutations on the letters A, B, C, D, E, F are there if each letter can be used only once? How many of these end in ED? How many of these begin and end with the vowel A? Okay. So if you have 1, 2, 3, 4, 5, 6 letters, and each letter can only be used once, okay, how many different permutations are there? Okay. So, in the first case, how many different permutations would end in ED? Well, if you are saying that the permutations you want end in ED, that means that the last 2 positions you already know are ED, and you know that they're not being used in the other positions. How many other positions are there? There's 4 other positions, right? Because there's 6 positions total. So you know that E and D are here, and then the remaining letters, which are A, B, C, and F, are being put in the first 4 positions. So you have 4 symbols, A, B, C, and F, being put in here, this position, this position, this position, and this position. So basically you have 4 factorial permutations, okay? 4 times 3 is 12, times 2 is 24. So basically you have 24 possibilities for A. What about C? It says begin and ends with a vowel, A or E. Okay. So that would mean that one of the possibilities would be A, blank, 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 E. So like all the permutations that look like that. And the other one would be starting with E, and then blank, 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 and then ending in A. Okay? So these would be the 2 possibilities as far as like what it starts and ends with. And then in between, you could have the remaining letters, which would be B, C, D, and F. So B, C, D, and F could go in the 4 slots in between in any order. So that would be 4, 3, 2, 1. And this would also be 4, 3, 2, 1. So the first one would be, again, 4 factorial, which is 24 permutations. And the second one would also be 24 more permutations, because this is like totally different because it starts with E and ends with A. And then basically you would add those 2 together to get the total number of permutations that begin and end with a vowel A or E. Okay?